Audio. Okay, I don't know if you were hearing me before or not, but I think we're up and running now. So I got a request to do the 43 questions on that worksheet that you had today. It looked like people got through about 10 to 15 problems. And so Tuesday's test will have everything. Anything that's on this worksheet might be on a test, and that holds true for the rest of the year. So we want to start looking at things, some of the things you haven't seen as much of, and some you've seen quite a bit of, which means you should be experiencing the ones you've seen for a while should be easier and quicker as you keep going. And the ones that you are just starting to look at, got to process and work with before it becomes easier to do. That's just how it's going to work. We've got a good, at least 50% of the term in front of us, about 60%, I would say, of the terms in front of us. And by midterm, we'll have the entire term in front of us. And then it's just the second half, practicing worksheets, talking about the concepts, understanding the history behind it, the geometric implications, so on and so forth. All right, but let's have at it. The first 10, most of you have already done, so I won't spend too much time. Can you see? Yes, I got to check the computer.
Minus 17 pi over 6 is really close to minus 18 pi over 6, which is negative 3 pi, which is on this side of the circle. So we want one less. So one less will put us, chunk of 6 is 30 degrees. So there's negative 1/2, there's negative root 3 over 2. There's 1, there's our triangle. And so we're going to look for the cosine, which is the width. So that's negative root 3 over 2. 27 pi over 4 is pretty close to 28 pi over 4. 28 pi over 4 is 7 pi. And we're one less going in this direction. So we should be pi over 4. Boom, and we're looking for the sine. That's negative root 2 over 2, which is approximately negative 0.71. Tangent of pi over 2 is straight up. So the tangent is height over width. In a unit circle, it's height over width. And so the height's 1, the width is 0, and 1 divided by 0 is undefined. All right, so this is drawn in standard position. I gave you little a is 6. So therefore that's little b, but we don't care. We don't have to draw that. We have enough information in front of us to make a mathematical equation. I'm looking at the cosine of that angle equals 6 over 7. Many of you went to Google. I had a cosine inverse calculator open, and the angle B is equal to the inverse cosine of 6/7. And so this is a ratio, and that language takes a ratio and gives us this angle. And I think it was around 31 degrees with some decimal place accuracy beyond that, certainly. Okay, and I think the camera worked well for all of those. Yes. So moving the camera further along. Next section. Yes, we're visually good. So this arc sine is the same thing as saying inverse sine. All right, and I don't see a famous ratio here. So I have to decide, do I want to draw this in the first or the negative first quadrant? I definitely want to draw it in the negative first. So that's the opposite to hypotenuse ratio. And a little Pythagoras finds the square root of 5 because this gives me an angle. That angle is, looks like it's about negative, it's between negative 0.71 and 0.5. So it's between 30 and 45. So maybe it's a negative, if I drew it better, negative 40-degree angle or something. But I don't need to know that angle to answer the question. The cosine of that angle is root 5 over 3. Then you can replay this and play it as many times as you want. So I'm talking fast. I am doing it fast. You can always replay everything. Slow it down. Oh, so width. I want my width to equal 1/2. So where in the circle are my widths equal to 1/2? Well, I know there's no widths right there. I know my farthest width to the right is 1 at 0 degrees. I've got a width of 1. I want a width of 1/2. So that's what the base of the triangle is going to look like. And if I go back up or down, I hit the circumference of the circle. And I can see that I have a 60-degree reference angle. 60 degrees is the pi over 3s. So I want the first one. I don't want the second. I don't want the third. I don't want the fourth. I think I want the fifth. So 5 pi over 3 and pi over 3. And just layer that with 1 period of the cosine function. That's 1 period of the cosine function. Remember, the width is at 0 degrees. My width is a max, and that max is 1. So 0 gets me 1, and therefore 2 pi brings me back to 1. And we want a half. Well, that's in the first quadrant and the fourth. The first 90 degrees and the last 90. The first 90 and the last 90. Then we can kind of corroborate our answers. Sine of pi over 4, 5 pi over 4 is an angle written in radian measurement. And that should locate you there. And we're looking for the inverse of this angle. Okay, well, the inverse of that angle, not arc sine, that's the full circle. I am now going to take this altitude right there and I'm going to shift it over here to the arc sine. The arc sine is between 90 degrees and negative 90. And I'm giving you the ratio. Now, what is the sine of 5 pi over 4? Take more time with it. You should get minus root 2 over 2, which is, I hope, pops into your head as negative 0.71. So this ruler goes down to as low as negative 1. And it starts at 0. And so that's halfway there, 0.75. So I'm a little bit shy of negative 0.75. So if I get a good drawing, somewhere in there, all right, I'll doctor that up with an eraser. You're trying to memorize the range. The range is the answers. So the arc sine, that's negative 1. We said pi 5, 7 pi, right about here. And I hope that's a pretty decent looking root 2 over 2, negative root 2 over 2. So we know that that angle is 45, but I'm moving in the negative direction. So that answer is minus pi over 4. Right? Because I'm giving you a ratio. There's only 2 things we do in trig. I give you a ratio, you give me an angle. When I give you a ratio, you're looking at this language: sine inverse, cosine inverse, tangent inverse. For the most part, that's the commands that require a ratio when you're dealing with angles. The sine, well, 30 degrees. Cosine, 30 degrees. You're putting angles with that language. Righty. So arc cosine, this is a ratio. You need to know where to locate it on the arc cosine, which is the top half of the circle. Negative root 3 over 2 is about negative 0.87. Good drawings get good answers. There's negative 1. There's 0. There's negative 0.5, maybe right about there, somewhere in between, right? So that's 7, 5, 87, way over here. And if you draw that, I hope you're seeing a reference angle of 30 degrees. But how do you get there? It's got to be 150. And that is pi over 6 is 30. How many 30 degrees are there in 150? 5. So there's one chunk of 6. 2, 3, 4. Yep. Yep. The sine, was it cosine? Cosine. So let me erase here. So the cosine of 5 pi over 6, I bet big bucks that the class now, more than half the class will get that right, is negative root 3 over 2. Therefore, 5 pi over 6 is equal to the arc cosine or cosine inverse of negative root 3 over 2. So this language works on a ratio to give me an angle, which I prefer to write in radians because that's what people work with. All right, so let's move this desk up. Now we're doing some more problems. Going to get 43 of these done. I better pick up the pace. I talked to a lot of people today. Cotangent of x equals plus minus 1. People are still forgetting the plus minus. Cotangent is really the width divided by the heights in the unit circle, and that occurs at the 45s. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And I'll just do one of them. I'll just do the pi over 4. Show you that it's equal to 1. So pi over 4. You got your root 2 over 2, and you got your root 2 over 2. And when you divide width by height, you get what you're looking for. So the angles we're looking for are all the odd pi over 4s. Speaking of, well, that's not pi over 4, it's 4 pi over 3. Plugging that in, we were evaluating. So the issue here is 4 pi over 3 minus pi. Hopefully you're getting better with your fractions. 4 pi over 3 minus 3 pi over 3 is the same as 4 pi over 3 minus pi. So that gives us pi over 3. Sine of pi over 3 is root 3 over 2. 2's cancel, and our answer is root 3, approximately 1.73. All right, I gave you a graph. If you located some places, they were pretty, that one was definite. 0 gave you 1. And if you look at the x-axis on your sheet, 0.7 got us 2. And the limit as x goes to negative infinity, the more I head to negative infinity, the more I head to numbers like e to the minus 100, which is 1 over e to the 100, which is still positive, but really close to 0. So there's asymptotic behavior. So that graph was y equals e to the x. I asked you to graph the inverse. So the inverse of 0, 1 is 1, 0. The inverse of 0.72 is 2.7. I'll bet you 3 is 1.1. I'll bet you negative 0.7 is a half. I'll bet you negative 1.1. I think we're starting to see, and the inverse of y is 0 is x is 0. I think we're starting to see the ln function here. So the inverse of e to the x is ln of x. What do we use ln of x for? Solving any e to the x equation. What do we use e to the x for? We can use it for modeling anything out there that's exponentially growing or decaying. And if we want to solve an e to the x, we got to use ln. If we want to solve an ln equation, we got to use e to the x. It's called changing from logarithmic to exponential form, or vice versa. I see angle A. I mean, the information was, I don't remember what I was supposed to look for. Oh, I think we're trying to find angle A. Given little a is 5 and little b is 6, I'm seeing the inverse tan of 5, 6 will get me angle A. You can go to Google and type in inverse tan calculator, and you can perform that calculation, and it will give you an angle. That should be less than 45, right? This number, the width is a little bit bigger, so my angle is a little less than 45. You want to take the time to look at Google and type in inverse tan calculator and do that, you'll get a good decimal approximation. All right, so now we got a linear function. Not going to take any time with that, just going to write it. So I started 5 to 20, I go up 15, negative 2 to 8 is 10. I don't care if you reduce that, x plus 2 plus 5, we're done. Can you see that? Yes. Let me pull it down just a little bit more. There we go. Okay, so that one's done. All right, so I'm trying to find the exponent on top of 7 that gets me whatever exponential activity occurs here. So 4 minus 2 is 2. Negative 2 times 2 is negative 4. So I want to change this into that, and I guess I got to get rid of the 7, and I got to bring in the negative 4. So I get rid of 7th power with the 7th root, and I bring in the minus 4 power. All right, I'm going to divide by negative 2. Then I'm going to do the change. Okay, so I guess I'll just make that negative 2 right now. Okay, so how do you handle logarithms? You change it into exponential form. Here's an easy exponential form to generate. So what is the exponential form? I'm sure you're all saying, oh, 25 comes from 5 squared. Same information, expressed differently. So x minus 2 is not finding exponents, but using them, and that is an exponent. Right? A log is an exponent. So therefore, this statement giving us that value, that's got to be an exponent. So now we have x equals 2 and 1/16. moving right along. So you could do these conceptually, or you can do them algebraically. Algebraic is going to come to most of you first. I know I got to take a fifth root. And I know I got to do that fifth root 4 times to get to 16. And I know that it's got a reciprocation. So I know my answer is -4/5 in terms of the operations involved. I hope you think about it that way. But in order to solve it, we rewrite 32 as 2 to the 5th. And I'm looking for the exponent that changes this into 1/16, which is 2 to the -4. I hope you can now look at that and see why -4/5 is the answer. Cube root of 127 is 1/3. You know what? I think I would have done the flip first. So 27 to the 4/3. I did the reciprocation. I performed that operation, so it's been done. I'll take the cube root of 27, which is 3. That's still left, and 3 times 27 is 81. So that's that one. And I think I captured it all on film here, on video. Just dated myself. I don't know if there's anything such thing as film anymore. All right, so I gotta graph this, which means that I gotta find the vertex. I know the y-intercept is on the increasing side, so I know that's 0, 11. All I gotta do is find the y-intercept. You're probably saying to yourself, minus b over 2a, which is the average of the roots. You know, if you got roots of a quadratic, right, you got 2 roots, then what's right in between is the x value of the vertex. I just made a mess on the floor. It's okay, I'll get to it later. So I now know my x is positive, so 4 goes into 16, 4 cut in half is 2. If I drop a 2 in, I get -16 plus 32 plus 11. And so that is 16 plus 11, 27. That's a good graph. So when I ask you to graph a quadratic, I want the y-intercept and I want the vertex. If I don't get that, you don't get that. Okay, so I'll repeat it. When graphing a quadratic, I want the y-intercept and I want the vertex. And if you got that, God, you got the roots immediately. So what are the roots? Well, to get to 0, I got to start at 2 and move to the right or move to the left. So I would hope that someone would say that 2 plus or minus. I got to go down 27 units. Actually, it's going to happen over here to hit that value. All right. And so I know I got to go down 27 to hit 0, but I'm multiplying by -4. So I really only want -1/4 of that. And if I'm squaring, well, there's your roots. A negative into a negative is a positive, right? And actually the 4 square root of 4 is 2. So I could have expressed it as the square root of 27 over 2. And that's somewhere between 5 and 6. Divided by 2 is somewhere between 2.5 and 3. Plus 2, minus 2, whatever, minus. You get a feel for the numbers. So I know that x squared, 0 squared is 0. So that's all I had to write. Now when I put a 5 in, it generates some numerical activity. What numerical activity gets generated? 25 units of numerical activity. I only want 1. I don't want the 25, I want the 1. That's the adjustment you need to make to get the graph, the parabola that goes through 5, 1 and has 0, 0 as a vertex. Pretty wide in terms of visual. All right, quadratics are set to 0. That's best. So I'm going to set this to 0. I'll move the 10 to the other side. I'm going to hope this is factorable. So I'm going to run some numbers through my head. I don't like 4 and 1. 4 times 1, 4 and 2. 2 times 4 is 8. Wait a minute. 1 and 10. 1, 2 and 5. 2 and no, 2 and 5. 4 and 1, 5. No. So I think we're going to go 2x, 2x, and I think we're going to do. Can I do it? My brain is a little tired right now. So 10 doesn't get me there. 5 gets me close, but not times 2. Oh, 5 and 2, yeah, 5, 10 and 2, no, that doesn't 3. B squared minus 4AC, A is 4, C is minus 10, and that's 16, 169, so 13 works. So if 13 works, then come on, brain, come back to me. So it is factorable. Okay, this is in the way. I got to get it out of the way. So I got a 4x and an x, and I'll have to look up that problem again. So I've got possible 1 and 10, 2 and 5, 5 and 2, 10 and 1. So 5, 20 and 2, there's no way that's going to work. 8 and 5, there it is. So it's the 5. So it's the 2 and the 5. Took me a while, sorry. So 2 and 5, and I want a negative, so that's going to be the positive, and that's going to be the negative. And so now I can see my answer is -5/4 and +2. I just needed a little space because the brain was a little tired. You always try to factor them if possible. If not, you got to put them in graphing form and solve, or you got to know the quadratic formula, which I haven't used in 10 or 20 years. I did use the discriminant to see that it was factorable, but I generally just look at the vertex and go from there. Alrighty, so what was the problem that I missed? I don't know, we're not doing it. So x minus 2 times what? X squared minus 5x plus 9. I'm doing this because I think that you studied long division in Algebra 1. You may have also done synthetic division in Algebra 1. More likely that you did synthetic division in Algebra 2. And I think that it's probably useful to go back to where did long division and synthetic division come from? Try to answer these types of questions. And you don't need to use long division. You don't need to use synthetic division. You can just write your answer. And then if the numbers get more challenging, yes, you probably need to keep track of what you're doing. And that's what long division is for. I see no reason to do synthetic division anymore. We got computers, we got calculators. There's no reason to know how to do that. Can't imagine. So how do I get to -5x? Well, x minus 3, right? Then those two numbers add up to -5. Now the question becomes, when you multiply this out, you get x squared minus 5x plus 6. And I'm trying to get from 6 up to the constant 9. So I got to go up another 3 units. But the problem is, how do you get 3 when you're multiplying something by x minus 2? Well, honestly, it's the same conversion principles that we've been using for linear functions, quadratic, square roots. We're going to use in sinusoid. We use it everywhere. And trying to get you to see the art of symbolic conversion. If you don't want that multiplication, use division. Get rid of it. All right, now when I multiply by x minus 2 out here, this are going to cancel, and I can go up 3. Now, this could have been written differently than, that's a 3. I'm sorry, it's a, somebody's pushed down really hard on the marker here. So let me see. I could have written this as x minus 3 plus 3. And that's why I think ancient mathematicians, you know, old guys like me, did years ago. And so if you look at x equals 2, and you drop 2 in here, well, that's 0 times anything is 0. A 2 gets us a 3. So if you want to find out on a test if your remainder is right, see if a 2 gets you a 3 in your final answer. So 2 squared is 4 minus 10 plus 9. Wow. 13 minus 10, 3. Okay, that's a correct answer. All right, and we're going to do just 1 a day, maybe 2. At some point, we'll do 3 or 4 in a row if you're having trouble getting it. Right now, exposure. All right, so what do I have to do here? It's probably easier to do it mechanically than it is to actually think about the operation. So 16 is 2 to the 4, and that's to the x minus 1. 8 is 2 to the 3, and that's to the x minus 2. And you got to be careful of making an algebra 1 mistake. So I'll do it up here because I don't want to erase another one. So 4x minus 4 is the exponential activity on the left. Since the base is the same, the exponential activity has to be the same. I have to distribute 3x minus 6. So therefore, x is equal to add 4. Let's see, I brought that this way, add 4, so negative 2. All right, that's that. Get some room here. So I could do Pythagoras. If it's 45 degrees, 45, 45, 90, then that's a 7. And if I do the Pythagorean theorem, I get the square root of 98, which is 7 root 2. But when I see an answer like that, I'm never doing that again. I think I know how to get from the smaller or the equal sides to the hypotenuse. I think I know now that 1.41 times the smaller two sides gets me the hypotenuse. And dividing by root 2, just like the 30, 60, 90. The only thing you got to remember is root 2 is what connects the sides. Sometimes you're multiplying by root 2, sometimes you're dividing. All right, let's see. I don't know how far this is, but you can always zoom in. Putting it a little bit further away here, but I want to get to lunch, so I'm just going to keep moving along. All right, so perpendicular is minus 41 over 33. X, I don't remember what I said to put it through. Let's do AB. There's your perpendicular. We can see that that number divided by that is a shortcut. If you don't take the shortcut, you got to look at what you're multiplying x by. And I can see that I'm multiplying by 33 over 41, changing y 41, changing x, changing x 41, changing y 33. And how do you take perpendicular to a slope like that? Negative reciprocal. So I hope you can see that we've got a positive here, a negative here, and the rise over run becomes the run over rise, and enough said. All right, 30, 60, 90, if that's 10, then that's 5, and that's 5 root 3. Cosecant is the reciprocal of sine, so that's the same thing as 1 over sine squared x, times tan squared x is sine squared x over cosine squared x, which gives me 1 over cosine squared x. I should have done this. This is a kind of a simplification that's going to take this right out of the ballpark. So let me see. X squared minus 4x plus y squared plus 2y equals 20. I'll come to that in a second. All right, so what have I got? I guess I can use the eraser here. So the sine squared, so 1 over cosine squared. And you should be using this Pythagorean relationship, so not drawn as squares, shortcut notation. Right, so that's what we're working with right now. And I said I got 1 over cosine squared x minus 1 is what we're working with now. All right, and so the other triangle we're working with is just the sine of an angle, and we'll call that x, the cosine of an angle, and 1. And I'm doing 1 over cosine. 1 over cosine is the reciprocal of cosine, and the reciprocal of cosine is secant. Secant squared x minus 1. And on your memorization sheet, you wouldn't know this yet. I put on your memorization sheet 1 plus tan squared x equals secant squared x. So secant squared x minus 1 is actually tan squared x. I would not expect you to have any success with that at this point. All you're doing is trying to follow what I said, and I did it quickly. So you might want to replay it once or twice. But when we do something called identities, we're going to get a lot of fraction practice and a lot of practice with substitution. And those are 2 foundational activities that we do in math all the time. We substitute simpler statements for more complicated ones, and we work with a lot of fractions, a lot of them. So we got to get good at it. So this here could have been written, the number 1, as cosine squared x over cosine squared x. Let's see if I made a mistake here. So that's secant squared x minus 1. No, okay. What else can I do? Oh, it might have been better for you at this stage to see if you can tell me what 1 minus cosine squared x over cosine squared x becomes. That's probably what I should have done for you as a show you step. All right. So we gotta go up here. What is 1 minus cosine squared x? Ah, looks like it's sine squared x. So I could replay, I'm getting tired. Rewrite 1 minus cosine squared x as sine squared x over cosine squared x. And I think I know what sine divided by cosine is. That's tangent x. Now, unless you work with these things a lot, and unless you start to look at these videos and really pay attention in class, you're never gonna get that. So you gotta put in some real effort here. Effortless effort takes effort. So if you wanna be able to say what these answers are quickly and easily, you're gonna have to put in the work. All right, so from your last level class, and I got a feeling that there's a lot of gaps. I hope you graph some circles. And the easiest circle to work with is the x squared plus y squared equals 25. Okay, so we're looking at x squared and y squared. We're going to add up those two columns and we want to get 25. 25. 25. So if I pick a number like 3, if I work with a 3, 4, 5 triangle, I can see that my x squared and my y squared adds up to 25 in this instance. So therefore, 3, 4 is on the curve. Let's call that 3, let's call that 4. So is 4, 3. 4, 3 is on the curve. So is 0 plus or minus 5. So is 0, 5 and 0, negative 5. So is 5, 0 and negative 5, 0. 5, 0 and negative. I hope you're starting to see the circle materialize. All right, so 25 is really 5 squared, and I hope you can see that this becomes the radius of the circle, and it's just, and we've been working with actually sine squared plus cosine squared x equals 1, which is circular as well. All right, so what does that mean? That means that we have to get, if we want to look at a circle that's not centered at 0, 0, right? I definitely want 0 squared plus 0 squared to be seen. I've got x squared minus 4x. Well, I know how to write that. That's simply x minus 2 squared minus 4. Called completing the square, right? Minus d over 2a. 4 divided by 2 is 2, so x minus 2. If you look at this and you square it, you get positive 4. I don't see any constants up here. We're going to move our constants to the other side. So that becomes x minus 2 squared minus 4. So let me put this up top here. X squared minus 4x. People don't have much trouble with these with a little practice. So I'm not going to talk a lot about it. Okay, so that could have been written as x minus 2 squared minus 4, and can you write that one quickly? Pause. Y plus 1 squared minus 1 equals 20. All right, so therefore I have x minus 2 squared plus y plus 1 squared equals, when I move the negatives over, 25, which could have been written as 5 squared. There's your Pythagorean theorem. So I now have a circle centered at 2, negative 1. We'll call that 2. We'll call that negative 1. And I have a radius of 5. There's my circle. And my center is at 2, negative 1. Why is this the graphing form? Because if you use a 2, well, that's nice. That part of the calculation is gone. And what plus 1 squared gives me 5 squared, or negative 5, right? So I can see that a 4 works. So 2, 4 is actually this location. And 2 squaring, so negative 1 down 5, negative 6. So if I put negative 6 in here, for instance, negative 6 plus 1 is negative 5. Negative 5 squared is the same as 5 squared. So that's what you should have done in Algebra 2, maybe Algebra 1. I do it in Algebra 1. I don't know if all teachers do. So you want to get good at that, which means it's now in front of us, so you'll start seeing it on every worksheet. And somewhere in the next week or two, I hope that it's something that's not too hard to work with. All right, so front board, 29 to 43. I'm going to pick up the pace. Just going to do these, not going to talk anymore. So what are we trying to find? A quick sketch. So when I'm sketching this, I see cup shape up. I see I'm on the downside, 0, -15. So I now know my x is positive. 2 goes into 12, 6. So I know it's 3 after that. And if I put a 3 in, -36 cut in half is -18, -15 is -23. That's how I do it. Cotangent squared x plus 1. Well, cotangent is cosine squared over sine squared. And if I'm going to add 1, I'm adding sine squared over sine squared. I can see cosine squared plus sine squared is 1. So 1 over sine squared. And the reciprocal of sine is cosecant. So this is the cosecant squared x. That's an easier thing to write than the original. So it's simplified. Okay, hopefully you saw that. Let's get the chair out of the way. Let's not step on my charger. Let's get that out of the way. And let's get doing this out of the way. Yeah. I'm guessing slope intercept form. So, so you got 44. I like to put it at the end. We're going to go to mx plus b. So -2/7x positive 2 over 7. Why did I give you this? 7 times 40 is 280 and 28, 308. So we got 308 over 7. So if I didn't make a careless mistake, which is quite possible right now, 310 over 7. You can tell me if I did that right tomorrow. So how do I solve ln? With e to the x, I'm going to change exponential form. So ln of 3x is equal to 4 divided by 4 is 1. Well, I know that has to be 1, so I know x is 1/3. Do I know that? So, no, I don't know that. It's got to be e. So it's got to be e over 3. Okay, anyway, we don't write the base, but changing this to exponential form is I put the exponent on top of e to get 3x. So 3x comes from e to the 1. Now I can see it. X equals e over 3. So if I put e over 3 in here, what happens to the 3's? They cancel. What exponent do you put on top of e to get e? 1. What's 4 times 1? 4 plus 2, 6. Doesn't hurt to check. Otherwise, you might make a careless mistake. F to the 1/5 brings us back to a previous problem. We're just doing practice fractions. Want to get good and quick and easy. So I'm going to put a 1/5 in here. I'm going to put a 1/5 here. And so what does that get me? That gets me 2 over 25 minus 12 over 5 minus 15. So I think I'll multiply everything by 25 and then divide by, do I want to do that? Yeah, let's play with it. Let's see if it's quicker. So I multiply by 25, I get 2 minus 60 equals 25, 15 quarters. 12 quarters is $3, so $3.75. Okay, and now I've got, why did I say equals? It's just minus. So this is minus 435 plus 2, minus 433. And then I'll come back and I'll divide by 25 because I really don't want to make it 25 times bigger. So I don't know. Check that one too. I'm running out of breath here. So I'm about at it. The old man's tired. But I'm hanging in there. Effortless effort takes effort. I'm giving it the effort. But right now, it's not effortless. Can you see this? Yes. All right. So what's the best way to handle this? Let's see if getting it to 0 helps us out. Oh, that's really nice. I can divide by 2. Oh, this is really excellent because I can factor it. Thank you, Lord. Answers 1 and 5, which means minus b over 2a in the original has to equal 3. Let's see here, not the original, but there. Minus b, 12 over 4 equals 3. Yeah, minus b over 2a. Whoa, just gives us the average of the roots. So now I want to do the inverse. Well, I guess I gotta change ln into e to the x. So let's see, let's call this x. Let's call that y. And let's move everything to the other side. Let's take addition of 2 and make it subtraction of 2. Let's take multiplication by 5 and make it division by 5. Let's do the inverse of ln of. And the inverse of ln of is e to the. There's that answer. That's the inverse. Study inverses so you can figure out how to solve equations. What do we got left here? We got this board. All right, gonna take the shortcuts. I think we can see everything, I think. So I'm gonna square that. I'm gonna double that product. I'm gonna square that. And I know that's -9, so 16 plus 30i. F of x, so the inverse of this. So I'm gonna switch the x's and the y's. So there's your y, now I gotta solve for x. I'm gonna subtract 2. I'm gonna divide by 5. I'm gonna do the inverse of e to the, which is ln of. There's the inverse. All right, almost done here. So I'm gonna add 2. I guess you can see. I'm gonna divide by 2. I'm gonna do the inverse of exponentiating base 2 is changing to log form. Log base 2 of 6. Now, to get a decimal equivalent, you'd have to go to E notation in our class. But we're only after x, and we'll get an exact answer here. So division by 2, multiplication by 2, subtraction of 2, addition of 2. Now, what do you put on top of 2 to get a 6? I'm just curious. E to the 0.7 to the x equals e to the 6 is 2 times 3, which is 0.7, and 1.1, which is 1.8. So it's 1.1 divided by 0.7. I don't know, 1.6-ish. So this is about 1.6-ish. 740. 7 goes into 4. Oh, Christ. 7 into 11. 1. 4 and a 0. So 5, 1.5. So somewhere around 1.5. I don't know what I'm doing anymore. I forgot what I was doing. So that one's done. So the tangent, another name for the tangent, sine x over cosine x, that's getting multiplied by sine x, and that's getting added to cosine x. I'm going to work with the eraser here. So sine x times sine x is sine squared x. So I can do that. And now I got a fraction. So I guess I got to make this over 1 and do bingo, bango, bongo. So let's see. You're just learning how to do this quickly. So, all right. So I know I need a common denominator of cosine. So what do I divide cosine into to get cosine squared? Did I say that right? Oh, I don't know why I did that. I guess I was talking. So this is where we should have been, right? Obviously, to get that, this has to be cosine squared x, because cosine squared x divided by cosine x is another way of saying that. Oh, I see sine squared plus cosine squared. Oh, that's 1. Oh, 1 divided by cosine, you would think would be cosecant, but it's a math class, so it's secant x. I'm almost ready to go get some chow. Okay, there you go. Put a punctuation mark on that. All right, next. Don't you die, battery. Don't you die. I guess you can see. Yep. All right. So what do we got here? What did I ask you to do? Minus 2/5 x plus 6 plus 4. Maybe I asked you to find values that work. So -6 changed by 5, -1, 4, down 2 from 4, 2, 0. So those are some coordinates that work in here. 67, 43, b is 5. God, why did I give you this? This is the law of sines. You might have done it in your geometry class. I don't know. But the law of sines says that, or the reciprocals of what I'm going to write. So the sine of angle A compares to its opposite side, the way that sine of angle B compares to its opposite side. And then you have the sine of angle C comparing to its opposite side. All right. So obviously we don't have a 90-degree triangle, right? If you add those up, it's over 90. So we are now studying non-right triangle trait. And so the sine of 4067 compares to, we don't know, but we do know that 43 compares to 5. So we don't have to use this one at all. And so now we got an easy cross multiply and solve. So what I like to do, and it's been a while since I've done it, obviously, because I should have said I'm looking for A. If I'm looking for A, I like to put it in the numerator of the first fraction. So therefore, the sine of 67 could have been written in the denominator, and 5 could have been over here, and the sine of 43 degrees in that denominator. And so now I can cross multiply. I hope everybody knows that trick. 1/4 equals 2/8. If that's true, then 1 times 8 has to equal 4 times 2, and it does. So therefore, 5 times the sine of 67 degrees has to equal A times the sine of 43. God, I'm tired. 5 times the sine of 67 degrees equals A times the sine of 43. Can you estimate the sine of 43 degrees? Should be near 0.71, a little smaller. So how do I get A alone? I just divide by the sine of 43. Okay, now there's no reason not to introduce the law of sines and start working with it. It's a piece of cake, so it shouldn't take us more than a day or two. Just have to memorize it. And I'm going to put it in front of you every day, so you don't have a choice. The ln of 3. The ln of 3 has no meaning unless it's above E. There's no function. There's no purpose for this kind of number unless we're attaching it to E. Okay, so when would you double that exponent? When would you double it? You double it when you had a 2 and on top of it, right? That's the rules of exponents. This 2 doesn't affect the base. It affects the exponent on the base. And that's what generates something like that. So what's another way of saying this? Well, you could have moved the 2 here. And then what is 3 squared? Because it has nothing to do with, this 2 has nothing to do with the command. You're doing this number and you're squaring before you take the natural log. So that becomes the number 9. And I've used that operation. Obviously, this 3 could have gone there. Same thing, 27. And I've used that operation. And I guess that's a 5. I don't know if I copied this right or wrong. I don't know. So what do we got here? We got subtraction and addition, but addition's commutative. So I could have written this as the ln of 9 plus the ln of 5 minus the ln of 27. And these are exponents. When do you add exponents? Well, in this case, when you're looking at the quantity 45, right, which is 9 times 5. And 9 is 3 squared, which is 1.1 doubled, right? So all that stuff's happening here. When do you subtract? In a division problem. Now, I've been giving you these. And what have you been doing? You've been starting to write 9 times 5, and 27 is 3 cubed, and 3 is e to the 1.1, so on and so forth. There's subtraction. So subtraction implies division. Addition implies multiplication. That's where those exponential rules come from. And I'm tired. I'm done. I'll go eat, and then I'll post this when I come back down the hill.